Example 5. Establish the identity tangent of x plus cotangent of x is equal to the secant of x times the cosecant of x. All right, so when you look at this identity, you might be puzzled as to which side do I start with? Which one is considered more complicated because they're both kind of short and sweet, okay? When I look at this, I would go with the left side. The reason being, I kind of feel like there's more that you can do with it. Like tangent, I can make sine over cosine, and cotangent, I can make cosine over sine, and then I can add those two fractions together and get a common denominator. So I feel like it's going to go somewhere, if that makes sense, okay? So that's what I'm going to do. I am going to start with the left side of this identity and then use the fundamental trigonometric identities and some algebraic manipulation, and I'm going to try to get to the right side, okay? All right, so let's start. So I'm going to write down the left side. So we've got the tangent of x plus the cotangent of x, okay? So now I'm going to go ahead and use basic trigonometric identities. So I know that the tangent of x is the same thing as the sine of x over the cosine of x. Okay, so I'm going to put my plus sign in the middle. Cotangent of x is the same thing as the cosine of x over the sine of x. Okay, so now I'm going to go ahead and add these fractions. Okay, so to do that, I need to get a common denominator. Okay, so again, the best thing to do is to just multiply the denominators together. Okay, so the common denominator here is going to be the cosine of x times the sine of x. Okay, all right, so let's work on the first fraction here, the sine of x over the cosine of x. Okay, I'm going to go ahead and write it down. And we want the denominator to be cosine of x times the sine of x. Okay, so we've already got the cosine of x covered. So we need to multiply the bottom by the sine of x to get the desired denominator. But if we multiply by the bottom by sine of x, we have to multiply the top by the sine of x. Okay, that way we are multiplying by the quantity the sine of x over the sine of x. That's equivalent to 1, so we're not changing the original fraction, which is sine of x over the cosine of x, okay? All right, so that's that fraction. So now we're going to move on to the next fraction. We're going to keep our plus sign in the middle. The other fraction is the cosine of x over the sine of x. Okay, again, we want the denominator to be the cosine of x times the sine of x. Okay, so this particular fraction already has sine of x in the denominator. So in order to achieve the desired common denominator, we need to multiply the bottom by the cosine of x. Okay, if we multiply the bottom by the cosine of x, we have to multiply the top by the cosine of x. Okay, that way we're multiplying by the quantity cosine of x over cosine of x, which is equivalent to 1. So we're really not changing the original fraction, cosine of x over the sine of x. Okay. All right, so now when you look at these, both the fraction on the left and the fraction on the right, they have the appropriate denominator, okay? Cosine of x times the sine of x, okay? Remember, you can multiply in either order, so you can write the denominator as either cosine of x times the sine of x or as the sine of x times the cosine of x, okay? All right, so I am going to go ahead and simplify each of these fractions, okay? So this particular fraction on the left, you're kind of multiplying two fractions here. So you're going to multiply across the top. Sine x times sine x is sine squared of x. Okay, the bottom is going to be the cosine of x times the sine of x. Okay, then you're going to add this other fraction. Okay, the bottom is sine x times cosine of x. I'm just going to write it as cosine x times the sine of x so it matches the other denominator on the left. And then you need to multiply across the top. Cosine of x times cosine of x is going to be cosine squared of x. Okay, and now these fractions have the same denominator. So since we're adding, okay, we're just going to keep the same denominator, the common denominator, and then we're going to add across the top. Okay, so you're going to have the numerator is going to be sine squared x plus cosine squared of x. Okay, you should recognize the numerator as the Pythagorean identity. Okay, sine squared x plus cosine squared x is 1. Okay, so this is going to turn into 1 over the cosine of x times the sine of x. Okay, Now, remember, you have to glance back from time to time to see what your end goal is. Okay, we're trying to end up with secant of x times the cosecant of x. Okay, so we're almost there. Okay, we are now at this juncture where we have this fraction 1 over the cosine of x times the sine of x. Okay, you can break this up. This is the same thing as 1 over the cosine of x times 1 over the sine of x. Okay, if you write those two fractions separately and multiply them, you would multiply across the top. 1 times 1 would give you 1, and then cosine x times sine x would give you the bottom cosine x sine x. Okay, so you can take this fraction right here and break it down into these two separate fractions that you're multiplying. They're equivalent. Okay, all right, so once you make that realization, okay, you can rewrite that 1 over the cosine of x, that's the same thing as the secant of x, okay, times 1 over the sine of x is going to be the cosecant of x. And that is our end goal, okay? That's what we were trying to achieve on the right side. We were trying to get secant of x times the cosecant of x, and we got there. So we are done. We verified the identity, okay? So again, just to recap, we started with the left-hand side, tangent of x plus the cotangent of x, okay? And we immediately changed everything into sines and cosines and then started adding those fractions. So we used, some algebraic manipulation, some basic trig identities. We used the Pythagorean identity sine squared x plus cosine squared of x equals 1 along the way. And eventually we were able to get to the right side of the identity.